respected participants, scholars, and faculty members. Today is 16th April, and today we have two sessions. IoT device for precision agriculture by Dr. Amit Mishra, Thapar Engineering College, Patiala. And second session will be on lawful interception and monitoring in 5G by Sri Ashok Kumar. On the onset, I welcome Dr. Amit Mishra and extend sincere gratitude for volunteering for taking session in this faculty development program. Dr. Amit Mishra is an esteemed associate professor in the Department of Electronics and Communication at Thapar Institute of Engineering and Technology, Patiala. He has over 9 years of expertise in both undergraduate and postgraduate education. His academic journey commenced with a MTech degree in system engineering from Dayal Bagh Education Institute, Agra in 2001, followed by a PhD in soft computing from Jamia Millia Islamia, New Delhi in 2010. With a rich professional background, Dr. Amit Mishra has served as a lecturer at GLA Institute of Technology and Management, Mathura, and as an assistant professor at JP University of Engineering and Technology, Pune, Madhya Pradesh. Presently, he serves as assistant professor at Thapar Institute of Engineering and Technology, Patiala. Dr. Amit Mishra is renowned for his specialization in developing AI-based IoT systems tailored for precision agriculture applications. His notable achievements include the development and validation of a low-cost autonomous LoRa WAN system for soil health monitoring under the Digital Village Research Project funded by TIET TAU Center of Excellence for Food Security T2CEFS. Additionally, he has pioneered an AI-based irrigation system designed to regulate water distribution, especially for water-intensive crops such as rice, wheat, and sugarcane. Currently, Dr. Amit Mishra is actively involved in the project RF Energy-driven wireless sensor network for IoT-based precision agriculture under TIET VT Center of Excellence in Emerging Materials, CEEMS. He holds a patent for two prototype products suitable for precision agriculture and industrial applications, and he is a certified drone pilot. His research interests span wireless communication, IoT system design, and neural network design. Dr. Amit Mishra has supervised 12 MTech dissertations, 5 PhD theses, and has contributed over 45 research papers to reputed national and international journals and conferences. Moreover, he has been recognized with the Best Paper Award at the International Conference on Information System Design and Intelligent Application held in Visakhapatnam in 2016. Dr. Amit Mishra holds two patents under review. They are low-cost autonomous green energy-based LoRa WAN system interfaced with an integrated 7-in-1 soil sensor, and second one, autonomous smart sustainable IoT-based system for optimizing water utilization in food, in flood or drip irrigation. With this short bio, I take a privilege to invite Dr. Amit Mishra to deliver his lecture in this session. Dr. Amit Mishra, over to you.
Okay, thanks, Dr. Madhukarji, for the brief introduction. Good morning, everyone. I am Amit Mishra over here, and I'm going to take a little presentation on the IoT devices for the precision agriculture. All right, it is related to my institution, Thapar Institute of Engineering Technology. It's the oldest and finest educational institute established in 1956 and covered the 250 acre of the area, and more than 8,000 students has been registered in this institute. Well, as far as outline of this presentation is concerned, we will talk about the motivation, data-driven precision agriculture, commercially available products in the market, basics of IoT systems, and our contributions. Especially for the motivation, as we see that we observe that the soil quality and water level in many parts of the India, especially in the northern region, has been deteriorating by many reasons. And some of them are illustrated over here. That may be due to the excessive use of water, due to the excessive use of pesticides and insecticides, maybe lack of awareness of organic fertilizers, and the pressure of the high yield again on the farmers, and back-to-back crop sowing season. So these are the few major uh, points which actually enhances the soil quality and water level deterioration. So what should be the solution? So the solution is given by the data-driven precision agriculture. So the question is again, what is data-driven precision agriculture? As far as data-driven precision agriculture is concerned, we use the uh, advanced technologies in the field of agriculture, whether it may be IoT devices, GPS, GIS, remote sensing, especially drone and satellite kind of thing, hyperspectral camera, maybe multispectral camera. And based on these devices, we collect the data. And data is stored on the cloud. And based on the cloud computing, we can analyze this data with the help of machine learning or maybe deep learning. And we try to predict some kind of useful recommendation, which may be useful for the farmers. Uh, so this is nothing but the concept of data-driven precision agriculture. So we are focusing in the area of IoT devices. So my team is working in this area, and I'll give you few uh, um, examples in this field. So as far as product available commercially in the market, because we are very much concerned about the soil health. So we try to make sure that soil health should be monitored continuously. So for that purpose, we need to uh, see the commercial product available in the market. So these are the few commercial products available in the market. One of them is Antratech, which is a solar-powered LoRaWAN soil moisture and EC sensor gateway. Again, Touch Techno is also providing the some of the solutions, and Libilium is again one of the international company which actually captures this market. And Fossil Agri product, this also gives us some of the solutions. So as far as the tentative cost of these product is concerned, what we see that among these, two of them are based on the LoRa communication, and two of them are again on the cellular communication. But as far as cost is concerned, it's too costly. Means it would be very very difficult for the farmer to purchase these kind of devices for this for his field, and and get the information from there, because farmer needs the very cost effective kind of solutions. So these are the beyond his purchasing power. So that is how we actually have the motivation. So motivation is to design in-house kind of product which may be useful and very very cost effective as far as Indian farmers are concerned. All right, as you can see over here, this LoRa communication modules have this is a tentative cost. LoRa communication modules have two parts in the module. One of them is sensor node, and other one is the sensor gateway. So actually, sensor node captures the information of the soil health from the sensor with the help of sensor, and it sends the information to the gateway, and gateway then transport this information to the cloud, push to the cloud. In the cellular kind of device is concerned. So in the cellular device, they capture the sensor information and directly send to the cloud with the help of cellular communication. So this needs only single block or single module, whereas LoRa needs two modules. One is sensor node and another one is gateway. All right. So need and objective, as I already told you, that to develop an autonomous, cost-effective, power-efficient, green energy-based robust wireless sensor network for soil health monitoring and precision agriculture. Actually, what happens as far as wireless sensor network is concerned, we know that we have commercially available sensors again in the market, which are available to you. I'll show it to the next slide. But the problem is the cost of the wireless sensor network, because these companies are charging too much for the wireless sensor network designing. So the gateway and the sensor node they designed commercially available in the market is too costly, because sensor cost is a very small, means that is not of very much costly, but the wireless sensor network has some kind of costly affairs. So we are trying to develop the wireless sensor network so that the cost-effective wireless sensor network can be created. All right. So as far as communication technologies are concerned, if we want to choose that which technology should be used for the precision agriculture, so we can see in this graph that communication range versus power consumption, if we compare both of these, so NFC and RFID, near field communication and RF identification, this may consume very less power, but at the same time, communication range is very, very small, near field, 1 meter or not more than 1 meter. So as far as short range is concerned, so near field is not fit for the agriculture. As far as short range is also concerned, there are three options: Zigbee, BLE, Bluetooth, low energy, and Wi-Fi. But again, the range is very short. So this again does not suitable for the agriculture. What we see over here that Sigfox, LoRaWAN, NB-IoT, LTE-M. These are the LPWAN system, low power wide area network systems. So these technologies are very, very suitable for the uh, agriculture. But as far as Sigfox and LoRaWAN is concerned, so when we compare the LoRaWAN and Sigfox, then we can find that LoRaWAN is communicating between node to gateway, right? And the cloud is connected so that the gateway can push the data to the cloud. So it needs the two things, node and gateway. But in case of Sigfox, it actually try to find the signal from the Sigfox node and directly send to the Sigfox cloud. So does not need the gateways at all. So Sigfox is a proprietary kind of technology. So we need to pay for it. As far as LoRaWAN is concerned, this is open source right now. So we can use the open source LoRaWAN communication without paying any money. As far as NB-IoT is concerned, NB-IoT is also one of the technology in the LPWAN. It has more data rate as compared to the LoRaWAN system, but again, it is a proprietary and not available right now in the India. LTE-M, CAT-M, Category M, Category 2 kind of thing is again available in the, it is in the starting position. Means it is just launching the establishing of the LTE-M kind of network. So we cannot rely on them right now. As far as cellular is concerned, 5G, 4G, 3G, 2G communications are the challenges. So what we are trying to do is we will try to implement the LoRaWAN communication in the 4G communication, a 4G kind of dongle, and we will try to implement this LoRaWAN updated for the 5G communication. So that is our task. So we have done the LoRaWAN communication in the 4G communication, and then we will try to implement in the 5G. All right. So as far as comparison of the technology is concerned, you can see in this table, the LoRaWAN, narrowband, LTE, LTE, CAT-M, Category M, and NB-IoT. These are being compared. Narrowband is unsuitable for the, just because data rate is very, very low, 100 bits per second. And bandwidth is very, very small, 100 hertz only. So as far as LoRaWAN is concerned, it gives us the means competitive environment for the agriculture, precision agriculture. As far as open source is the best part of the LoRaWAN communication. Now, this is a 4-layer open source, open system interconnection OSI model. Though the OSI model is 7-layer, but for the IoT case, it actually appears as a 4-layer or 5 layers. So first 2 layers being combined, and this is the physical layer, and then network layer, transport layer, and application layers are there, and different protocols are attached to the specific application or transport layer. As far as device classes are concerned, as I told you that in the LoRa communication, we have divided the devices into 3 categories: class A, class B, and class C. In the class A, what we interested is the communication between node to gateway. We don't want, though it is facilities available for the bidirectional communication, but we don't want bidirectional communication. We only want that the sensor node should send the data most of the time to the gateway, and if possible, a node is also able to see the some of the signal coming from the gateway, because there might be a possibility that node has some kind of actuators which may be activated with the help of the signal being sent from the gateway. So that kind of facility must be available to us also. So in the B and C category, we have this facility. So in the B, we have a beacon, which actually sends the availability of the signals coming from the gateway, and it receives that. Again, in the C also, C is fully powered actuator kind of communication module, which actually receives all the time the signal coming from the gateway, and there is no latency to activate the actuator which is placed at the sensor node. So in this case, the A, we are using the A just because we need to monitor uh, the soil parameters with the help of sensors. So that is why we use the category A. But category B and C are also available for the LoRaWAN communication system. So we can see over here. So in the class A, sensor sends the information to the gateway, and there is some delay, and this is the less opportunity, less duration is allotted for the signal to be received from the gateway. Similarly, so the use cases may be environmental monitoring, animal tracking, water leakage detection, smart parking asset, or maybe precision agriculture is most of the time. Similarly, in the class B, as you can see, there is a beacon which actually sends the information coming from the gateway. And after uplinking the node data to the gateway, it gives the RX1 and RX2 duration for sensing the gateway information to the uh, node for the actuator. And the utility maybe in the case of meters, water meters and street lights, these may be the application of the class B category. In the class C, as you can see, the class C always connected to the gateway, and it is always ready to receive the gateway messages to actuate the actuator coming information from the gateway. All right. And what would be the use cases? Use cases may be a street light, utility meters, beacon lights, alarms, some kind of industrial alarms may be possible. So this is how the ABC class has been classified. So we are using the class A kind of thing. Now, as far as device activation is concerned, LoRaWAN supports two ways of device connection, over to air activation and activation by personalization. What I feel that OTA, this is recommended that the OTA process is more secure than the ABP process, activation by personalization, because in the OTA we use the two identifier for the networks to check. Means there is two keys by which authentication can be done. So one is application unique identifier and application key. But in case of ABP, only session key is being used for the connection between LoRa module and the means the LoRaWAN gateway. So this session key is constantly not updating till the connection is made. So that is why the ABP is not much secure as compared to the OTA. So OTA is recommended that it should be used for the authentication or for the device activation. Now, the lead of objective is to develop an autonomous, cost-effective, power-efficient, green energy-based, robust wireless sensor network for soil health monitoring. So what are the steps involved? The steps are there. So first of the steps is the identification of the suitable sensor, selection of communication technology, specification of communication protocol, development of wireless sensor network device with the help of solar power and Wi-Fi capability. So solar power is a green power, so that is why we are using solar power. Deployment of the proposed wireless sensor network in the test field so that we can validate the information, and testing and calibration is also a uh, another task. So identification of the suitable sensor. So as far as suitable sensors are concerned, I told you that many sensors are available commercially in the market. So this is the capacitive soil moisture sensor, which is a very small kind of thing. It's a laboratory kind of activity. But in the industrial, we use the SS200 soil moisture sensor, soil pH sensor, NPK sensor. But using these sensors to get the information of the soil, instead of using the three sensors individually, we use single sensor, which is nothing but the 7-in-1 soil sensor, which can measure the 7 parameters of the soil at a stretch, right? So pH, electrical conductivity, moisture, temperature, nitrogen, phosphorus, and potassium can be measured with the help of this 7-in-1 soil sensor, which is the industrial one. The cost of this sensor is near about 15,000. So total cost of the LoRa network which we have produced, which we have developed, is 25,000. So 15,000 is alone the cost of the sensor only. So sensor we are not designing. So we are procuring the sensors from the market, commercially market, but we are designing the sensor network, wireless sensor network, LoRaWAN based. All right. Step two is the selection of communication technology. We have selected the LoRaWAN technology because due to the its application in the precision agriculture, longer range and low power, small data rate. So all these factors actually initiate its application in the precision agriculture. So as we can see, in as far as range and bandwidth is concerned, bandwidth is low. That is why the data rate is low in the LoRa communication, few kbps, 50 kbps, and bandwidth is also a low, but the range is quite long. So it compares with the cellular communication also. So that is why LoRa is being preferred in the precision agriculture. As far as the specification of communication protocol is concerned, especially LoRa, so we have some questions, kind of what is LoRa? So LoRa is abbreviation of the long range. So this that is why the LoRa, the word comes in, came up. And it is one of the major long range and low power wireless communication developed by the Stantec Corporation. It's a purely physical layer kind of protocol, right? And here is the medium by which LoRa nodes sends its information in the form of RF waves to the gateway, and similarly vice versa from gateway to uh, LoRa nodes. LoRa can be worked on the three sub gigahertz frequencies: 915, 868 megahertz, and 433 megahertz. In India, we are using the 867 megahertz. So that is the frequency which we have used. 2.4 gigahertz is also allotted for it. LoRa uses the chirp spread spectrum technology. So modulation is the chirp spectrum, CSS. So what we can understand the CSS just like the sweep of the frequency from lower frequency to high frequency. So this is the low chirp, and high frequency to low frequency again down chirp. So kind of thing we can easily understand with the chirp spread spectrum. Uh, to be more precise, okay, let us discuss the chirp spread spectrum. So as we can see, this is the digital modulation. ASK modulation is being done. So this is the binary information. We have chosen the carrier high frequency. So one multiplied with the carrier means the one will be represented by the high frequency and zero will be represented by low frequency. So kind of maybe uh, on-off keying can also be possible. So this is the ASK kind of means modulation, digital modulation. As far as FSK is concerned, FSK again based on the ones and zeros, low frequency and high frequency. It is in the frequency domain. So this kind of a spectrum we can see in the FSK, ones and zeros. But in the CSS, we see the sweep of the frequency deteriorating from low frequency to ranging from low frequency to high frequency, or maybe sweeping from high frequency to low frequency. So up chirp and down chirp kind of thing. So sweep of the frequency is taking place in the chirp CSS. So as we can see, this is the sweep, and bandwidth is over here. Bandwidth is because of it is scarcity of the bandwidth. So in the form of LoRaWAN, it is 500 kilohertz in some American standards, and European it is 250 kilohertz and 125 kilohertz kind of. So based on this lower bandwidth, the data rate is also a very small. Similarly, the spreading factor. This is one of the another factor means parameter for the LoRaWAN. So there are 6 spreading factors available. Spreading factor 7 to SF12. So we can see there is a sweep rate. Sweep rate is changing. So starting the higher sweep rate is 7, and lower sweep rate is. So we can see over here that the sweep rate is changing, and based on that, the spreading factor takes place. So in the smaller sweep rate, which is SF7, we can see that there is a bandwidth and the higher data rate will be there, and the location, but the range of the communication or the length of the signal transmission is very, very less. But as far as 12 is concerned, sweep rate is large. It can travel, the signal can be traveled up to a larger distance, but very small data rate. So that is how we choose the spreading factors. We choose the spreading factors 8 for our case. The coding rate. Again, the coding rate can be represented as 4 by 5, 4 by 6, 4 by 7, and 4 by 8. So 4 options are there. And among this, the 4 are the useful bits, and 8 is the transmission bit. 5, 6, 7, or 8 transmission bits. So as we know that if the transmission bits are larger, so the capability of the coding rate means capability of the code to combat the interference will be more, right? So that could be possible, but at the same time the data rate will be lesser because we are using the more transmission bits, and useful bits are the same. So that is why resilient with the interference of the 4 by 8 will be larger, but at the same time the data rate will be lower. Other physical parameters are concerned. So we have the bandwidth, code rate, the bit rate, transmission duration, and the spreading factor. So there is a relationship between spreading factor, symbol duration, and bandwidth like this. So TS is the symbol duration, bandwidth, and 2 raised to power SF. SF is the spreading factor. And another relationship between bit rate can be given as SF by TS. So spreading factor by TS is the symbol duration, and CR is the code rate. As far as LoRa frame is concerned, as we can see, as I told you that this is the LoRa frame. In this LoRa frame, we have 6 up chirp because lower to high frequency is sweeping, right? And 6 up chirps and 2 down chirps. These are the 2 down chirps. These 2 down chirps is used for sync signal. And after that, 4.5 symbols are for the symbols which need to be transmitted. So this is the data we are sending. So this is the one frame of the LoRa frame. Over here, it is also explanation of the up chirp and down chirp. So up chirp is nothing but the lower frequency to higher, it is up chirp, and from higher frequency to lower, it is down chirp. So this is the sweep. Over here, it can be seen. And the sweep offset, the frequency offset for sweeping can be easily calculated with the help of this formula, bandwidth divided by 2 raised to power SF into S, where S belongs to 0 to 2 raised to power SF minus 1, where SF is nothing but the spreading factor we have chosen. We have chosen the 8 spreading factor. Now the question comes, what is LoRaWAN? So LoRaWAN is a media access control protocol, which actually transfer the information from gateway to network, right? So that is nothing but the, it is a software layer which defines the how device use the LoRa hardware. For example, they transmit and the format of the messages. So over here, we can see the LoRaWAN architecture where these AND nodes are nothing but the sensor nodes, where the sensor has been established. So these sensor nodes can be placed at the field, and these gateway, the concentrator is nothing but the gateway. Gateway is placed somewhere else, means that is few distance, few kilometer distance over there. So there is a distance between AND nodes and concentrator. So what happens? The AND node sends the information and send to the concentrator or the gateways, and from gateways the information pushed to the network server, and from the network server we can use the application server for our any of the application which we are using, or for the data analytics purpose, right? So there are network server available, application server available. We use these and we will send the information from AND node to the cloud with the help of LoRaWAN protocol. What is LoRa Alliance? Actually, LoRa Alliance is the open non-profit association which actually taken care with supports for the development of the newly versions of the LoRaWAN protocols. So there are a lot of versions which have been already released. So first version was released in the January 2015, and latest one was October 2020, 1.0.4. So this is the latest version right now we have. These are the LoRaWAN network server available to us, and these are the free application server for the IoT systems. So among them, we are using the Things network in the LoRaWAN network system and ThingSpeak. So we have chosen these two. You may choose any one of them. So these are the application server which are available to us, free application. So we can register the free, we can register these application server by using our email or some kind of authentication, and we can use it. The thing is, Peak has some facility that it can show you the data logging as well as the chart wise parameter fluctuation. So if temperature is being readed, means measurement is taking place. So temperature can be seen on the XY chart kind of things. So the movement of the temperature rising or falling can be easily visible in the form of chart. In the Blink also, there can be a facility to activate uh, the actuators also. So if the actuator is placed at the center node, that can be handled with the help of, that can be controlled with the help of Blink. So application server can send the message to make the motor turn off, turn on kind of things. So that can be possible. Now, as far as specification of my product is concerned, so this is the hardware specification. We are using the ESP32 microcontrollers. Operating frequency is up to 240 megahertz, and these are the other specification of the microcontroller. As far as data communication, because we have chosen the LoRaWAN, so these are the communication protocols. So sensor node, we are using the two sensor nodes. Frequency, we are using 866 to 867 megahertz. Spreading factor, we have chosen the 8, and kind of these are again other communication distance. We have kept 800 meter or 1 kilometer kind of. Power consumption in the microcontroller, again, we are using the sleep mode, so we can reduce the power consumption also. So that is why this becomes the power efficient. Enclosures, the box in which the device is protected is of IP65 mark and made up of polycarbonate, and sealing is polyurethane. As far as sensor is concerned, we have used the 7-in-1 soil sensor specification. So it can measure 7 parameters, and these are the resolutions and the specification of the sensor. It has the IP68 kind of protection level, so waterproofing is there exactly. Now, this is the development of wireless sensor device with solar power and Wi-Fi capability. So this is the customized PCB we have designed in our lab, and this is the LoRaWAN sensor node. This is the PCB over here, and the connections. This is the ESP32, and some connection has been made. This is the sensor 7-in-1. This is the box enclosure. So the sensor node looks like this, and the gateway we have again developed, and with the help of gateway, the communication takes place between sensor node to gateway. So this is the sensor node, and this is the gateway module, which has been placed in 1 kilometer away from the sensor node, and it can receive the data from the sensor node by with a distance of 1 kilometer or more. These are the parameters for the sensor node and gateway device again. Now, these are the deployment of our sensor node in various fields. So we have various villages nearby the Patiala and Ludhiana. So Manjal, Khurd, Field 1, Field 2, KVK, Krishi Vigyan Kendra. We have MOU with the PAU, Punjab Agriculture University, Ludhiana. So we are using their fields to establish our deployment of our devices. And we are getting the sensor data from these fields. And we are measuring these information, and we are doing analytics, data analytics on these data. So as far as testing and calibration is concerned, so this is one of the simple kind of validation of the sensor data. So we take the temperature sensor, which is being received by this sensor node, and we also capture the meteorological data with the help of this MERA site. MERA is nothing but the modern era retrospective analysis and research analysis application part version 2. So this is the meteorological data which is available on the MERA site. We downloaded that, and we compare the same data on the same field on the same location. So coordinates are same, and the data is also for the same field or for the same locations. So what we see, this meteorological data is available for the 2 meter above the ground, but the sensor data is available below the ground, below the 6 inches down the surface, right? So we can see the difference between them, but the variations we can see that is quite similar. So the temperature above 2 meter of the surface and below the 6 inch, that could resemble to each other. So variation is same, but the temperature is different just because the outside and inside temperature is quite different. So this is one of the uh, testing and calibration we did kind of thing. So that is how we test the information which is received by the our sensor node. Now the second part, we have completed the image of the autonomous. This is the image of the autonomous water controller. So the concept of water controller is, because we have already talked about the water level deterioration. So this is the methodology we are using. Trying, we have the overhead water tanks which is filled up the water, and from this water, or maybe some kind of tube well is there, submersible pump is there, so the underground water can be fetched from the water pump, and that can be filled into the water. So that is uncontrolled one. But what we did, we place one water controller in between the water which is coming from the uh, water pump and is going to the ground or into going to the field. So between this, there is a controller, and that controller is being controlled by the information which is coming from the sensor node, which is placed in the field. So the node which is placed in the field sends the moisture information, and based on the moisture information, it sends the signal to the gateway that the field is required irrigation, and then only the solenoid valve which is placed at the water controller is open, just because of the sensor information coming up, or request of the irrigation is coming up from the sensor node. So based on this information, the sensor valve, the gateway opens the solenoid valve, and irrigation takes place. So this kind of activity we have already done, and we have tested successfully. So this is the sensor node which is placed in the field far from the gateway. It's see the it measure the mean soil moisture and send the information over here. So this is the gateway over here. So these two are far away from 1 kilometer or so. So this information goes to the irrigation request goes to the gateway, and gateway opens this solenoid valve. There is a solenoid valve over here, right? And there is a 1 meter is there inside the pipe. So meter can record the water flow, or maybe the quantity of water being irrigated to the field, and this solenoid valve will be activated once the request will come from the here. So these are the meter, solenoid valve, sensors, and ultrasonic sensors kind of things. So these are the two interventions we have done. We have successfully write the patent for it, and they are in process. And that is how we completed our work. Now, the question comes that how to implement LoRaWAN using 5G network. Will it be possible? So as far as this concern, I have seen the paper in which some of the main scientists is being means are busy to use this kind of implementation. So what they did, they have the LoRaWAN and device. This is the sensor node, and this is the LoRaWAN gateway. They have used the Raspberry Pi. I have used the ESP32 controller. Doesn't matter, but this is the gateway, and this gateway is connected from the 5G dongle to the G node B of the 5G communication, and from the SI interface, it actually communicated to the core network of the 5. So kind of this thing is being done in is in progress. So my task will be in future to implement my work onto this 5G network. All right. So these are the important links for this presentation. Uh, so thank you, everyone. If anybody wants to ask any question, please, is welcome.
Sir, may I ask one question?
Yes, ma'am.
Yeah, sir, it was really a nice presentation and research work also, what I can see from that your lab setups and those instruments that you have developed. But sir, can I ask one thing related to the costing involved into that, and how many number of LoRaWANs to be installed in the field? How that you have decided?
Okay, well, ma'am, it is decided based on the size of the field. So if 1 acre is there, so we know that the soil composition does not vary much in the 1 biga or maybe 1 acre of the field. So we decide to put two sensor nodes in the field into two extreme corners, and they can be communicated to one single gateway. Or maybe if the field is quite large, maybe 2 acre or more than this, so we can use the two or more than two sensor nodes over there. So at the same time, one gateway can handle more than two sensor nodes. So that can be possible. So we have used till date three sensors nodes to one gateway.
Sir,
And at the
good.
max, how many sensors are possible for one gateway, sir?
No, as far as sensor is concerned, sensor integration is only single sensor we are using 7-in-1 soil health parameter. So we can also integrate other sensors also, but there is no need because this single sensor can measure the 7 parameters simultaneously. So that is why we only integrate single sensor to the single sensor node.
Sir,
And
I have
for
a
one
question.
acre area in the extreme corners, you have taken the two nodes, sorry.
Two nodes with
Two
two
nodes.
sensors. Means sensor is connected to the sensor node. So two sensor nodes are placed on the extreme corner of the field, and so we can assume that there may be a difference in the soil moisture or maybe some kind of things, because once we irrigate the field, so there might not be a same water placed in all the field, because there is a labeling although, but there is a difference between the soil moisture in the two extreme points of the field. So that is why we use two sensor nodes over there.
Thank you, sir.
Okay.
Sir, good morning, sir. I have a
Related to the
question.
same, I guess.
Yes, sir.
Good morning.
Sir, actually, is it economically viable? Because when I encountered some of the farmers, particularly those who are doing wet crop like paddy, they are spending almost 25,000 per acre.
Yes.
Even after spending 25,000, they could not able to take the proper yield from that. And in addition to this 25,000 per acre, if we implement this precision agriculture, that is any technology like precision agriculture kind of technology, that will add the further cost to the farmers.
Agree with you, sir.
Yeah, in what way it will be feasible to the poor farmers in India?
Yes, sir. Actually, the commercially available sensors node and wireless sensors available in the markets are too much costly. Means they are more than 1 lakh for one means a pair. So we have cut down the cost and taken it to the 25,000 only. But we need the support of the government also, because government is paying too much for the water and electricity. Means they are paying they have free electricity. They are giving free electricity and free water to the Punjab farmers. So instead of paying this kind of things, so they can give the subsidy to our devices, because we have we have filed the patent, and these patent device will be means maybe supplied to the farmers so that they can use it, and based on this they can save the water also. So this way they can get the both way facility. Means they can save the water also, and at the same time the free electricity and these freebies may be stopped, some kind of thing. So these the money which is being used in the freebies can be utilized in the kind of precision agricultures. So that is why our motivation is. So we are making a full plan, and we have making a case study, and we are going to present to the Ministry of the Agriculture in the Punjab. So we hope that this kind of activity or this kind of case study will means that influence the persons over there. Yes.
Actually, sir, as on date, say, for example, you take 2 acres of land. 1 acre
Okay.
of land is done conventional agriculture, conventional farming, same crop. And another 1 acre, assuming that we are implementing this precision agriculture technology. And
All
at the
right.
end of the day, if we show them the improvement in economy, then probably people may accept it. Is there any proof for that?
Yes,
As
sir.
on
Yes, sir.
date?
Yes, sir. We are doing the same case study for that. So what we did in the field, we have installed these kind of water controller sensor which can measure the controlled irrigation to the field, and the field which are being tested compared with the uncontrolled kind of field also. So the irrigation produced or yield produced by the uncontrolled or controlled manner is also being analyzed. And what we find that there is no crop drop or maybe yield drop between two uncontrolled and controlled, but we can save the lot of means amount of means that water saving can be saved, means that can also be possible. So this kind of case study has been already completed, and we have the proof of it. Yeah, POC. We have the POC of it. Yes.
Thank you, sir. Thank you very much.
Yes. Okay.
Can I ask one question, sir?
Yes, sir.
Sir, I'm Dr. Vetrigalan from VIT Chennai.
Yes.
Sir, regarding the precision agriculture, uh, the area-wise NPK proportion and suggesting appropriate crop, and every crop has got their own procedure starting from seeding to harvesting. So, is there any framework that you have deployed wherein as an end
So,
user, locality wise, they can search and get the benefits
well,
that is
sir.
possible to stay? Second question, yes, sir. Yes, sir.
All right. All right. Please
Hello.
complete the question, please.
Yeah, yeah. And another one, we have something called the NB-IoT. So as you deployed Moravine for a wider coverage, and is there any role or what the NB-IoT can be applied for the cases where short range communication or edge analytics where it is required? What kind of field or kind of what kind of in fact, this kind of technology can be suited. So that is what.
Okay, so as far as NB-IoT is concerned, NB-IoT is a proprietary kind of technology. So we need to wait for the means the tower has to be placed in the different locations so that the communication can take place. And NB-IoT hardware is also available in the market, but that is actually suited for the European countries or maybe America kind of thing. So we are trying to see whether the NB-IoT devices will be available for the India frequency kind of thing. So they must sync with the Indian frequency which we are using for the radio communications. So that's what we are waiting for. That is a good option as far as LoRaWAN is concerned. They also consumes less power and has the data rate, large data rate as compared to the LoRaWAN communication. And the range is also quite good. So NB-IoT is must be the best suitable means kind of if it is available to the India also. So that we are waiting. And what was the another question, sir?
Regarding
Okay.
NTP, is there any
Another,
government that got any initiatives taken up across the India, different locality, different NTP proportion in every area? We cannot cultivate all the fields in all the area.
yes,
So is there any?
understood. So the in the Punjab we have the two major crops, wheat and the rice, the paddy. So we have tested our devices on these two crops only, but we can test our devices to other crops also. So that is the pipeline activities which we are having in the future. So might be possible our device will be tested on the different crops also. Yes, just like cotton and sugarcane and other crops also. Yes.
Yeah, well, if you take Indian context, we have a lot of other fields, so like the dry field and the wet field.
Yes, sir. Definitely, sir.
Okay, sir. Thank you.
Sir, I'm Rajiv from Guru Nanak University.
All right.
Sir, I just want to ask about how can we create a gateway at the like sensor nodes?
Yes, sir. Okay, so there is a full tutorial over there on the internet. So if you want, I'll share it to you. And that is the single channel gateway. So we have developed the single channel gateway. Multi-channel gateway are more preferable because they are commercially available and they can accommodate more number of sensor nodes. So in our single channel gateway, we have accommodated more than two or more than four, just like this means up to four nodes can be accommodated on a single gateway. But in the multi-channel gateway, there may be more than 8 or more than 10 nodes can be accommodated. But multi-channel gateway is complicated to design. So we have developed a single channel gateway right now. So we are happy with it because 4 nodes can be accommodated with that gateway. Yes.
So, is there any specific hardware that we need, like
Not a
ESP
specific
would be?
not a specific hardware because there is a communication between the LoRa communication NRF 95 we are using for the LoRa communication. So ESP32 is the microcontroller we are using. So on both the sides, the same communication takes place. So from the sensor, nodes captures the information of the sensor, and the sensor data can be transmitted to the gateway by using the LoRa communication. So that kind of the firmware is written by us only. So we have given so much time for writing the code in the firmware so that that could be possible, because there are few things which may be kind of sometimes the gateway is stuck and this is this has become hang. So to avoid that situation, we have again inserted some kind of circuits in our gateway so that that could not hang up. So that facility we have created in our gateway. So that is a kind of research work, but ultimately we did it. Yes, sir.
Okay, thank you so
Sir,
much, sir.
I have
But
another question, sir.
yes, sir.
As an engineer, using technology, we can capture and can collect that field data. Do you have any tie-up with the agricultural scientists so that the proper decision can be taken?
Yes, sir. Yes, sir. We have MOU with the Punjab Agriculture University, Ludhiana, where the scientists have from the different departments have partners with us. They are joined hands with us, and we work with them. And we are placing our few sensors in that field also. Matlab in the Ludhiana PAU agriculture means Punjab Agriculture University fields, they have the experimental fields. So we have installed our devices in their fields also. So we are getting the sensor data and we are validating the sensor data with the help of that soil testing, the chemical testing proof. So we are comparing the NPK given by our sensor and NPK uh, retrieved from the soil kind of testing. So that we are doing with the help of them. Yes.
Sir, I have one question. This is Sanjeev Kumar. Uh, Actually, like as you have mentioned that you can maximum you can go for 4 or 5 sensors with the help of LoRa gateway, right, with single channels. So do we require 5G systems to like so we can do the similar things with the 4G itself? So how do you feel like the 5G will be helpful in that network?
Well, 5G will be helpful for us to get the more data rate enhancement. Right, that can be possible. Means more number of nodes can be accommodated and more data can be transferred through the 5G communication. So that can be means enhancement. We can get 5G communication.
So you did like several experimentations. So what other like challenges you have faced like in LoRa communications? What do you feel like still there is so much scope in that to like proceed in that directions?
Well, as far as the single channel is concerned, we do not face any difficulty after testing of this device, because before testing there were a lot of hit and trial. So we change our circuit accordingly so that problems may get rid of. So after getting the final design, we do not find any problem with the single channel gateway. So we are happy with it. But multi-channel gateway can accommodate more number of sensor nodes that we are that we know of. So
But
we will try to accommodate.
one common problem like we generally also face that the channel conditions also changes. Like the whatever we transmit, like that
Yes,
may
sir.
fail. So whenever we are
Packet
interested
loss. Yes,
to
yes.
actuate certain sensor, that may fail. So how what is that probability in your case? Like how much you had uh,
Okay.
faced that
So
type of situation?
the thing the problem you are telling me is the packet loss kind of problem, because we
Right, right.
actually activate our node for some time. Let us suppose 10 minutes or 15 minutes, and between that 10-15 minutes, it sends its data in form of the packets, and packet reaches to the gateway, and gateway intercept it, right? And
Right.
between that packet loss may occur, but we know that during that 10 minutes time, enough data can be sent, enough packets can be sent, so that the gateway can capture, means if there are hundreds of packets may be sent, so
Mhm.
among 100 there may be a packet loss, so maybe 10, 15, 25 packets will be available to the gateway, so that we can capture the information of the
Can
sensor.
solve the purpose, right?
Yes,
Okay.
sir. Yes, sir.
Thank you. Thank you. Thanks.
Hello, sir. Am I audible?
Hello. Sir, I have hello.
Yes, sir. Yes, ma'am.
Sir,
So
I have one more question.
Okay, ma'am.
Sir, for one type of crop, you have suppose you have completely implemented your setup, whatever the whole module what you have designed for
Yes.
one crop. Then you will be calibrating the sensor for that kind of crop for the moisture, for the temperature and everything. You will be calibrating. So if after some few months, when the farmer goes for the next type of crop, so he has to recalibrate the whole setup once again.
Yes.
So what is the recurring cost to manage this kind of module? And can it be done it has been taught to the farmers, or some professional is needed repeatedly to be called?
Okay, initially, what we are doing, we have calibrated our sensor for the paddy crop. So in the paddy crop, we use a lot of water. So we need to use the height of the water in the field as well as the soil moisture, right? Based on the decision takes place. So that is the part of the paddy crop only. So we make our system corresponding to the paddy crop, right? But once the wheat season comes in, so wheat season, the water required less, and there is no such kind of water level is available in the field, so there is no water level indicator is there, so we can absolute that, or we can take the moisture only. So based on the crop, the the full validation of the soil moisture and the system can be done again, because it depends on the crop to crop. So wherever the crop will change, accordingly the system has to be updated in the software, so the limitation, the threshold, and everything will be changed as per the crop. Yes, ma'am.
Hello, sir. Am I
That means
audible?
this kind of technology comes with a recurring cost also. Not only the initial primary investment, but also
Not
it
recurring
needs
cost,
a
not
recurring cost. The
uh,
farmer cannot set up do the complete calibration and do the needful. So he
no.
or she has to call a professional for that.
Yes, definitely. That work can be done with the help of a specialist only. And once the specialist finalize the full proof software for one type of crop, that can be handled by the farmer itself. So farmer cannot do these kind of experiment by alone. So some expert has to do it. Once the software will be ready for one crop, then it would be handed over to the farmer. So that is how we will planning. We will plan this.
Sir, am I audible?
Yes, sir.
Sir, I am Dr. Mallikarjun from SIT Tumkur, Karnataka. Sir, actually, we have also implemented so many projects using LoRa technology as well as LoRa WAN technology. And the major drawback what I found was the data rate. Do you agree, sir? So 125 KB, hardly the data what we can send. So the meaning is for soil moisture analysis, for temperature analysis, these kind of stuffs are fruitful. That's fine, sir. Now the 5G lab setup came into existence from the government of India. 100 use case labs has been sanctioned. So don't you feel, sir, like this setup doesn't have any sort of that stuff? So because we just have to do so many things associated with the disease detection, not only the temperature or humidity or soil moisture concerned, so many other stuffs on farm irrigation need to be done. If this costly equipment, once it has been installed, does it support so many other stuffs with the irrigation issues concerned? As the government of India planning to have the 5G use case lab for the agriculture concerned, the precision agriculture concerned, taking care of the entire stuffs with available large bandwidth, because this uses CCS spectrum, like so CSS, chip spectrum, and the data which has to be sent is only limited to 125 kb, so which is hardly used for soil moisture as well as temperature concerned. How about the other information like video information or the images which can be sent and analyzed with AI ML applications, which cannot be supported with LoRaWAN? I feel so, sir. What is your opinion in future, sir,
Yes.
with this setup?
Yes, sir. I agree with you. Yes, actually, LoRaWAN communication is only for these kind of devices which can measure the soil health or maybe soil crop health, right? But other devices such as the drone-based multispectral camera and the hyperspectral camera, they have the huge data to be transferred for the cloud. Yes, so that
Yes,
can
sir.
be possible with the help of this 5G communication, because these data is also useful to find out the or for the prediction of the weed in the crop, or maybe some kind of disease find in the crop. So that can be possible with the help of 5G communication as well. So we have the full proof system which includes the IoT devices based on the LoRaWAN communication, doesn't need the 5G communication. Okay, but as far as the drone and other remote sensing equipments are used, they have the huge data to be transferred. So that can be done with the help of 5G communication, and data can be accommodated to the cloud. And based on all these information, remote sensing, IoT, and all these surveys compiled together and make the machine learning algorithm, by churning the machine learning algorithm, prediction can be made. So that is how the 5G communication will be useful for the full irrigation kind of concept. So my opinion is
Uh,
that.
Okay, sir. Maybe,
Yeah.
sir. Like maybe the interfacing of LoRaWAN with 5G technology, if it happens, probably
Yes.
don't know, sir. Like how exactly the things can be realized. But as of now, the LoRaWAN setup, once the infrastructure has been installed, means it's very difficult to cooperate with the 5G. Then, as you said, if network compatibility comes,
Yes.
probably
Yes.
we may. Yeah, sir.
Definitely,
Yeah.
you are right, sir.
Thanks.
You are right, because LoRaWAN is the compatible for only low data rate communication. So
Yes,
how
sir.
the 5G communication will integrate with the LoRaWAN communication, that I have to see again, because we are
Okay.
working on it, and we will find the solution. That's all. Yeah.
Yes. Thank you, sir.
Okay. Yes, sir.
Sir, one more question I have.
Okay,
So
ma'am.
since because sir, you are working on this line, in this line, so you must have the knowledge of that. Besides this kind of setup, what you have designed, what other setups are there for precision marking which are in working condition currently implemented? Do you have any idea, sir?
Basically, I
Have you
am working
encountered
on the.
some?
Yes, yes, ma'am. Actually, in our institution, we are having the Center of Excellence for the Food Security. And under that Food Security Center, we are working in a digital village kind of project where all the activities, as I told you, the remote sensing activities using the drone and spectral camera. So we are actually means doing the activities or scanning the field with the help of a spectral camera and getting the data again. And we are using the camera to take the pictures or images of the weed and the crop. So all these activities are combined together. And my work is to take care of the IoT devices. So I have installed the IoT devices in the same field where the all these experiments are going on. So this is the combined activity, which is under the umbrella of digital village kind of project. So in that scenario, we are implemented. We have the POC, proof of concept, of these kind of activities. So all these activities are going on in the real fields. So so we have the proof of concept over these activities in our campus. Yes.
Yes. Thank you, sir.
Okay.
Hello. Hello.
Hello. Hello,
Sir, am
ma'am.
I audible? Sir, I
Yes,
have
ma'am.
one question. Sir,
All right.
my question is, as you mentioned, spreading factor is equal to 8. So, sir, is there any specific reason for choosing spreading factor is equal to 8? Because this is something like a longer range and a higher data. So, what is your concern for using this spreading factor is equal to 8? Higher data rate?
All right, no, yes, definitely, because in our campus we don't have large area to be tested. So in our lab, we were 800 meters. That's all. So we have we have installed our gateway and the node apart from 800 meters. So within 800 meters, the node and gateway was installed. So for that purpose, we do not require the 12 spreading factor, because the spreading factor, if you increase the spreading factor, the range will be increased, but the data rate will be
Yeah.
reduced. So that is how we actually chosen the 8. So for the testing purposes we have chosen, but in the real fields, what we find that direct communication, that line of sight communication takes place, and the distance of the between gateway and node can be increased very much. So beyond 1 kilometer can also be signal can be intercepted by the gateway. So range can be increased in the real fields, open fields. Yes.
But your main concern is related to data rate, not the distance coverage.
Yes, yes. We were talking about the data rate at that time. So we measure the data, how much data packets are being received at the gateway. But in the real field, once we tested it, we find the positive kind of results, and we get the enough data packets for each and every node. Yes, definitely.
Okay. So with the help of this, you are able to get the data for the longer range also, like 1 kilometer also. So it is a benefit for both the data rate and the coverage.
Coverage, yes, definitely. Yes.
Okay, so I have one question.
Okay.
Sir, as you mentioned, at the time of implementation, we used a LoRa node and gateways. So, sir, can we replace this LoRa gateway with some other SDR or USRP, or is it must to use that LoRa gateway for this transmission?
That I have not tested yet, because we have having the sync with the LoRa gate and LoRa node. So both sides, their LoRa communication receiver, transceiver is there. So we did not test it. We have did not test another kind of solution. So if you are asking that, that may be a reasonable activity for us for in the future. Yes, we will test it
Actually,
if it is possible.
I saw in papers. Actually, I saw some other type of like SDRs or USRPs for transmission, like HEC-RF and all those. So that's why I'm asking,
Yes.
did you try to
Might be
like
possible.
use that?
I didn't explore. Yes, yes. I didn't explore, but that might be possible. That is the interesting kind of activity. Yes, yes, that can be possible.
Okay, okay. Thank you, sir. Thank you.
Okay, ma'am.
Any more questions? So I think, Amit ji, it was a wonderful presentation, and also it generated a lot of queries from the participants. So perhaps everyone thinks or may like to replicate same or similar thing. So it's a very nice one project which you have done, and the beauty of your project is that you have done end to end, and also practical deployment has been done in your case. That's why it's generating a lot of interest and query. I don't know whether you have created some document around it, so that maybe kind of something which can be shared with all the participants, and that will help them replicate same or similar project in their institutions. That may be a request from our side to you, Amitji.
So actually, sir, we have filed two patents for these two interventions. So once it will be over, then I can share the information of these interventions to everybody. Yes, that can be
Okay.
possible.
Okay.
Yes.
Okay. Great. So in this particular whole setup, as you said that you have purchased these modules and also like done something. So what is the novelty which you are bringing in so that you are able to get a patent?
Yes,
So
sir.
what's yeah.
Yes, novelty is the we have developed the gateway itself by in-house.
Okay.
So we are not
Okay.
purchasing gateway from outside. Especially node is also being developed by ourselves. The only thing which we have purchased from the market is the sensor node and the patty components, means the the electronics components which will be useful to make the devices. So so that was our intervention. Yeah, that was our novelty.
Okay. Okay. There were so many questions that can we replace LoRa and have any other kind of technology?
Yes, sir.
So I think technically, since we are just transferring the data from the field to the gateway, so technically should be possible, but one has to work both side, same communication medium you may need, and then you can connect to your server. So technically should be okay, but one has to create that solution, just like you have done using the LoRa WAN. So if you want to use any other technology, technically it should be possible, but yes, both side interfaces need to be looked into. Am I right?
Yes, sir. Definitely. We are
Okay.
working on it, and hopefully we'll.
And yeah, and other thing which should be possible is like we are using our own kind of a connectivity from field to the server. In place of that, if you can use any commercially available coverage in that area, maybe 4G, 5G, or whatever coverage we may have. So it's a question of sending the data from field to your server, right? So
Yes, sir.
if certain commercially available communication thing can be used, then it becomes more practical, deployable to any field where you have a mobile coverage, right? So I don't know whether you have done something on that or it's there in your menu for future. So
Many for
that would
future.
also be a great
Because,
idea to do it.
that 5G communication lab is going to come in our institution, so I am the part of it. So I'll use that lab in in my work also. Yes, so
Okay.
definitely I'll use it.
So in case you want to, so in the current form of the lab is like in the lab environment only you have transmission. So maybe you need to seek some external base stations of that 5G. That
Yes, sir.
may be a additional thing which can be done.
Yes,
Or maybe you can develop that and connect to the same core in the sense that you can buy that radio from NI, build your own BBU or maybe use open source and try to do that. So that would be possible and that would really create a project for you.
yes, sir.
So thank you so much for your wonderful presentation. So over to you, Madhukar. Madhukar, you can open your mic for a
Thank you, sir.
follow-up
Yes,
vote of thanks to Amit ji.
yes. On behalf of Faculty Development Program team and participants, we extend our heartfelt gratitude to Dr. Amit Mishra ji for his insightful and engaging presentation. Sir, your expertise and your passion in this field of work were truly evident throughout your presentation, and the knowledge you shared has certainly enriched our understanding of all the attendees. Your presentations were clear and crisp to the subject matter and has inspired for further exploration and excellence. Your contribution on this diverse subject will certainly enrich our learning experience during this FDP. Once again, thank you, Dr. Mishra, for your dedication and expertise in contributing to the success of this session. Special thanks also goes out to all the participants for active and enthusiastic participation and your commitment for gaining exciting ideas and knowledge. The same was evident in the session, which created a vibrant and dynamic atmosphere throughout the session. Thank you, all of you. Thank you, sir. Thank you, Amit Mishra, sir. All
Thank
regards.
you.
Jai Hind.
Thank you.
Jai Hind.
Jai.
Thank you. Maybe we can discuss with all other participants